Hello students, in this video we will be reviewing the lesson 3-6 congruent triangles by side, 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 and side angle side. Let's get started with the do-not problem. Use the picture below to find the value of x. What we notice here is that we are dealing with three interior angles in a triangle. So we must recall the triangle angle sum theorem that states that when you add the three interior angles in a triangle, their sum equals to 180 degrees. Let's go ahead and set up the equation. 8x minus 35 plus 6x minus 5 plus 3x minus 1 equals 180 degrees. Since we have multiple x terms and multiple constant terms in the same side, on the left, we're going to be combining these. 8x plus 6x plus 3x, that's going to give us 17x. Then we have negative 35 minus 35 minus 1, that's going to give us negative 41 equals 180. Notice that we simplified our first equation to now this two-step equation. So we need to get rid of the constant plus 41 by doing the inverse operation. And we get 17x equals 221. Then get rid of the coefficient by dividing, and we get x equals 13. Since the question was only asking us to find the value of x, we have done with our problem. All right, moving on. The objective for today is students will be able to prove that two triangles are congruent by side, 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 and side angle side. Well, yesterday in lesson 3-5, congruent triangles, we were able to determine that when two triangles are congruent, those two triangles will have the same shape and the same size. Also, we were able to identify the 6 pairs of congruent corresponding angles and corresponding congruent sides. There were 3 pairs of corresponding congruent angles and 3 pairs of corresponding congruent sides. Well, today I'm going to be showing you 2 shortcuts that would help you to prove that two triangles are congruent only if you're able to find that the 3 pairs of corresponding congruent sides are congruent, and if you have 2 pairs and an angle. Just want to let you know that there's 5 in total. Okay, the 5 shortcuts that would help you to prove that two triangles are congruent are the following: side, 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 angle, side, angle, side, angle, 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 side, and HL. Today we're just going to be focusing on the first 2. Okay, again, these are shortcuts. Instead of us finding the 3 pairs of corresponding congruent angles and the 3 pairs of corresponding congruent sides, if we use these shortcuts, this will be enough information for us to determine that these triangles will be congruent. Okay, let's get started with the first shortcut. The first one is side, side, side. It states here, if 3 sides of one triangle are equal to the 3 sides of another triangle, then the triangles are congruent. So if I tell you that this side, oops, I'm trying to choose a highlighter. If I tell you that this side is congruent to this one, okay, and this side right here congruent to this one, then the longest sides are equal as well. Remember, we can put the same number of ticks to indicate that. 1, 2 in the green sides, and 3 on the pink ones. Whenever you have a situation like this, we notice that the yellow sides are going to be congruent, so I can come back and place an S. For sides, I have found one pair of sides that are congruent. We notice that the green sides are going to be congruent, so we can come back and place another S. And then we notice that the pink sides are also congruent, so I can come back and place another S. When I'm trying to determine what shortcut I'm using, I'm only going to be looking at one of the triangles. Okay, so if I use one of the triangles, in this case I'm going to use the one on the left, I notice that I have 3 S's, right? So this is a shortcut, side, side, side. Here, because, oops, hold on. Here, because we know that 3 sides of one triangle are congruent to the 3 sides of another triangle, this is enough information for me to say that these triangles are congruent. I don't care about the angles. As long as I'm able to prove that 3 sides of one triangle are congruent to the 3 sides of another, then these triangles will be congruent. This is our first shortcut. For the second shortcut, side, angle, side. It says here, if 2 sides and the included angle, that's super important, the included angle, which is the one in between the 2 sides, so if the 2 sides and the included angle of one triangle are equal to the corresponding sides and the angle of another triangle, then the triangles will be congruent. Let me show you the example. If this side and this side are congruent, and this side and this side are congruent, then we know we already have 2 sides. Sides, the pink sides, and then, oops, we have another side right here. Okay, and we need the included angle. That included angle needs to be the one that is in between the 2 given sides. So it has to be this one right here, because that's the one that is in between those 2 given sides. It can be just any angle. It needs to be that included angle. So I'm going to place an 8 right there. And again, like I said, in order for you to read that specific shortcut, you need to just use one triangle, okay? And you follow the order. So we have side, angle, side. And if you go reverse way, you can also will see that it's the same shortcut, side, angle, side. Okay, so here the shortcut is side, angle, side, and this is enough information in order for me to prove that these 2 triangles will be congruent. Now, I just want to also let you know that there's some reasons that you need to remember in order for you to determine that you have an extra pair of sides that are congruent. So that would be like when it's given, when the markings are there in the triangles. Obviously, for example, I'm just going to give you an example. If you have 2 triangles like this, and this is A, B, C, D, E, F. If there's the same number of ticks, then you can say that BC, side BC, is going to be congruent to side EF. So when it's given, when it would be given, if they will be telling you in the instructions, or because of the markings, you can conclude that that's a pair of congruent sides. Another way of determining a pair of congruent sides will be when they're giving you the definition of a midpoint. So for example, if they give you something like this, if they say M is the midpoint of side AB, Then because M is a midpoint, then you know that M is splitting that segment AB into two congruent parts. So therefore, you can come back and place those ticks because M is a midpoint. And you can conclude that AM, segment AM, is going to be congruent to segment MB. Again, definition of the midpoint, automatically you should remember that the midpoint will create two congruent sides. And then another one will be reflexive property, which you would be seeing that one a lot. So the reflexive property states that a side can be congruent to itself. So if you're given a triangle like this, in reality you have two triangles here, okay? And you're given that these two sides are equal and these sides, the hypotenuse of these right triangles are equal. Then I'm going to label these A, B, C, D. Then you can conclude by the reflexive property that BD is going to be equal to BD because BD is equal to itself. And that's going to give you an extra pair of sides. I always like to put the X to indicate that that's for the reflexive property. And again, the reflexive property gives me an extra pair of sides. So for this particular problem, right, or example, you have one pair of sides. You have the hypotenuse that are congruent. And then because of the reflexive property, you're able to find that third missing side. Okay, so then this would be side, side, side. Don't forget the reflexive property. Okay, it states that a side can be congruent to itself. All right, I'm going to go ahead and erase this. Now, how can we find an extra pair of angles? Well, when it's given, right, when the hooks are there, and when we have vertical angles. So sometimes you're going to be finding triangles like this. They're going to say this angle is equal to this one, and so on and so forth. But then you should be able to recall here the vertical angles. So if you're able to recall vertical angles, then you can come back and place the same number of hooks because you have identified vertical angles and vertical angles are congruent. Again, I don't want you to just come back out of nowhere and start putting ticks and start putting hooks, markings on your diagram without a justification. You need to get one of these rules, right? Reflexive property, vertical angles, alternate interior angles, alternate exterior angles, corresponding angles, and angle bisector in order for you to come back and apply those markings. If you cannot justify why those are congruent, then you cannot come back and place any markings on your diagram. All right, I'm going to move on. I'm going to give you some non-examples. So it says here, be careful, caution, right? So it says do not use AAA or the donkey theorem. AAA means that we're given all the three angles of two triangles but no sides. The donkey theorem is pretty self-explanatory. Use it forwards or backwards. Okay, so basically I'm going to explain to you what is the donkey theorem right now. So, but let's go ahead and get started with the first one. So if we look at the first triangle, set of triangles, we know that we have one pair of angles that are congruent right there, right? Because it has one hook. We have a second pair of angles with two hooks. And then, very good. Some of you guys are already able to recall that we can come back and place three hooks here because these are vertical angles. but vertical angles is going to give us an extra pair of congruent angles. But you need to understand that the shortcut here, when I'm trying to label the shortcut or name the shortcut, I just look at one of the triangles and I follow the order, right? So this is angle, angle, angle. And if I go backwards, it's still the same thing, angle, angle, angle. But that is not enough. That is not going to be enough information. And I'm going to tell you why, okay? I'm going to tell you why real quick. When you have a right triangle, you can have two right triangles with the same angles, 30, 30, 60, 60. But these two triangles will be similar because although they're the exactly same shape, they're two right triangles, their sides are going to be different lengths, right? So they have different sizes. So because of these, having angle, 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 it's not going to be enough information for you to determine that two triangles are congruent, that they're the exactly same size and same shape. Sorry about that, guys. They were messaging me from school. Okay, moving on. So the next thing is looking at the second non-example. In this non-example, you have a pair of sides, another pair of sides with two hooks, and so that's it. I don't want you to come back and start putting more ticks here. You can't do that. There's not a property or a rule that is stating that you can go ahead and do that. These are not midpoints. We don't have a bisector here. Nothing is telling us that those are congruent. We don't even have a ruler to measure them, so you can't do that. So the shortcut that you have here is just SS, but that's not enough information. We need at least 3 items, so that is not enough information. The other one, the donkey theorem, guys, is going to be the one when you have angle side side. So let me go ahead and see if I can copy something like that to model for you guys. What's also another non-example. If you have angle side side. So you have here angle, and then you have here side, and then you have another side. This is the donkey theorem, right? Because if we look at the order of the shortcut, we would have that, which is not a good word, right? I'm just gonna write it reverse way. So because, okay, that is not enough information, then we can use that theorem to say that this will be enough information to prove that these two triangles are congruent. Remember, the angle must be the included angle. So the angle must be the one in between the two given sides. So if that angle, instead of being here, would have been here, in between the two given sides, then that would be side angle side, which is one of the shortcuts, right? But right now, this is SSA or ASS, which is not a good word, right? And so we know that that is not enough information. Okay, that does not work. Super important. It seems like it seems like it's a lot of information, but for right now, we're just focusing on the side, 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 and the side angle side. Let's go ahead and do some practice problems. Here we have one pair of sides, one pair of angles, and one pair of sides. When I'm looking at the pattern or the shortcut, right, I use the order, and I notice that this is side, angle, side. So that's one of my shortcuts. So then these two triangles are congruent. You're going to come back and say triangles are congruent by side, angle, side. All right, the next one. We have a pair of sides, we have a pair of angles, and we have another pair of sides. We follow the order just by using one triangle, so we have side, angle, side. I know that this is the angle in between the two given sides, so my shortcut is side, angle, side. That is one of my shortcuts, so I can conclude, that the triangles are congruent by side, angle, side. Next one. I have a side, I have another side right here, and then notice that a side can be equal to itself, so I put an X for reflexive property, and that's going to give me an extra pair of sides. Again, that is a reflexive property that states that one side can be equal to itself, and so we have side, side, side. On the next one, we have a pair of sides with one tick, another pair of sides with two, another third pair of sides with three different markings, ticks. So when we use the shortcut, when we're trying to label the shortcut, which is just one triangle, and this is side, side, side. So triangles are congruent by side, side, side. All right, next one. We have a side, an angle, and then reflexive property once again saying that two sides are equal to, it's equal to itself. A side is equal to itself. So when we're trying to determine the shortcut, we follow the order on one triangle only. So this is side, angle, side. So triangles are congruent by side, angle, side. On the next one, we have a pair of sides with two markings. And then we have another pair of sides with three markings or ticks. So here, I cannot come back and add anything else. I don't know anything about the angles. I don't know anything about the sides. So here we only have SS. And notice that's not one of the shortcuts. We need at least 3 items. In this case, we would need to know that the third pair of sides are also congruent, but there's nothing that is going to support that. So then this is not enough information. And we don't know if the triangles are congruent or not. On the next one, we have a pair of angles, right angles, another pair of angles with 2 hooks, and then I can come back and add the 3 hooks here because what's going to support me doing that is that I'm recalling that these are vertical angles, and vertical angles are congruent. So that's going to give me a third pair of angles. So when I'm trying to determine the shortcut, I notice that this is angle, angle, angle. But I know that angle, 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 it's not enough information. And I need to be able to remember that example that I gave you with the right triangles, that you can have similar right triangles. And so angle, 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 having 3 pairs of corresponding congruent angles is not enough information to determine that these triangles are congruent. For the next one, we would do the same. We have angle, 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 angle. And again, I end up with angle, angle, angle. And I know that this is not enough information. All right, for your independent practice, you would have to determine if the triangles are congruent or not. And you have to tell me if they're congruent by side, 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 angle, side. Okay, remember the ones that don't work? The ones that would give you not enough information is the angle, 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 and the angle, side, side. Oops, that's a bad word, right? We don't want to use that one. I'm going to reverse way. Just so you can remember, okay? That is not going to be enough information, okay? And then I'm giving you some review problems that I want you to practice on for lesson 3-3, which is isosceles triangles, and then lesson 3-4, which is equilateral triangles. So make sure you complete those. You take a picture of your work and you submit it into the assignments.